Okay, I think we are recording fine. Let's start. This is October, November 2025. This is 6-1. This is an S2 exam. Let's begin. The random variables x and y have independent distributions 3 and 2. Find the probability of between 2 and 5. So that means I want to calculate the probabilities of 3 and 4 only. Okay. So I'm going to write down the expression. I'm going to say e power minus 3 uh, 3 cube over 3 factorial plus 3 power 4 over 4 factorial. Okay. And I will get you an answer that says on my calculator 0.392. Okay, moving on. X plus y. So I'm asking you to create a new Poisson distribution for the total, which is 5. So probability of total is greater than 2. So 1 minus probability of 0. So I really want what? I want 3, 4, 5, and so on. So I will do 1 minus probability of 0, 1, 2, 1 minus e power minus 5, 1 plus 5 plus 5 square over 2. Okay. That should give me a final answer that says 0.875. Okay, that was easy. The total of 100 random variable values of x and 150 random values of y is denoted by t. So 3 and 2. So 100 into 3 plus 150 into 2. So what is the new lambda that I'm working with? It's 600. I want to calculate the probability of t less than 560. So if I'm using a normal distribution, I must first do continuity correction. 559.5 converted to z 559.5 minus 560 divided by, sorry, not 560 minus 600 divided by root of 600. Okay, because t will follow, I should write this, t will follow a normal distribution with 600 comma 600 now. Okay, let's c is less than minus 1.653, pi of minus 1.653. I think I have a table open here. 9508. 9508. Okay, so 0.0492. That should be the correct answer. Okay, moving on. Question number 2. The mean mass of packets of 2 leaf is supposed to be 500 grams. An inspector wishes to test whether this value is correct. He weighs 600 randomly chosen packets and notes the mass x grams of each packet. The results are summarized as follows. So test at the 5% significance level whether the mean mass is 500 grams. So H naught is 500 and H1 is mu is not equal to 500. Okay. What is my critical region? My critical region is on both sides, 2.5% on both sides, 2.5% and 2.5%. Okay. So alternate hypothesis is because I'm testing whether the value is correct. It could be both in above or below 500. I don't know for sure. So that's what I'm doing. Okay. So 2.5% gives me 1.960. So I have minus 1.96 and plus 1.9. I'm going to calculate my test statistic to 9970 divided by 60. That's 499.5. Okay. Now to calculate the z value of my test statistic, I will need a value for sigma. Okay. How am I going to calculate sigma? I'm going to do sigma square is basically n over n minus 1 60 over 59. I'm going to unbias it. Unbias what? The sample variance. Okay. Narrowly avoiding that margin, but you should try to do it in a better way on the exam. Minus 499.5. Right. To 60 divided by 50. So 4.8305. Okay, so z is going to be x bar minus mu over root of 4.8305 over root of 16. Okay, then 499.5 minus 500 root of 4.8305 minus 1.762. Is this in the rejection region? Let's check. No, it's not in the rejection region. It's falling somewhere here. So fail to reject H naught. There is not enough evidence to support the inspector's claim. Okay, moving on. We then have question number 3. The data produced by a data entry firm always includes a small number of incorrect characters that occur at random. The proportion of incorrect characters is denoted by P, and experience has shown that P is 0.0001. That's really small. A particular data set contains 14,500 characters, of which X characters are incorrect. Use a suitable approximation to find probability of X less than 4. So with less than 4, I have to calculate the probabilities of 0, 1, 2, and 3. But since P is small and N is large, I'm going to use a Poisson distribution. I will calculate the lambda, which is NP, which gives me 14,500, 0.0001. 3 zeros and a 1. So 29 over 20 gives me 1.45. So e power minus 1.45, 1 plus 1.45 plus 1.45 squared plus over 2 factorial plus 1.45 cubed over 3 factorial. Okay, that should give me a value I want to calculate, and that gives me 0.94. Okay. The firm's management wishes to decrease the value of P by giving their employees some training. Their aim is that for data set containing 14,500 characters, the value of 0, but the new value of P should be double the value of this when P is equals to 0 0.0. Use a suitable approximation. I'm again going to use a Poisson distribution. At one end, I'm going to say that the P is P and N is 14,500. On the other end, I'm going to say that P is 0.001, P is 14,500. Okay, the probability of 0 here should be twice the probability of 0 here. So that was easy. 2 power e power minus 1.45. I already have that. When I am doing this, I'm going to say e power minus 14,500 p. Okay, so minus 14,500 p equals to ln 2e minus 1.45. I can do this directly. P. So p is then ln 2e power minus 1.45 divided by minus 14,500. Get a very small answer, that's 0.0000 5 to 2. Okay, because that is what the management wants. It wants to decrease the value of p. So that's the correct answer. Then it says the mass of a certain species of animal are known to be normally distributed with standard deviation sigma. The a researcher obtains the mass of a random sample of n animals of the species and uses this mass to find two confidence intervals, alpha percent and 90% for the population mean. The width of alpha percent is 1.414 times the width of 90%. So width has a formula 2 times z value into sigma over root n. So 1.414 times z value sigma over root n. Okay, I know that root n is the same for both. That cancels out. I know that standard deviation is the same for both. So 2 times z value equals to the value. Now this is the value of alpha percent and this is the value of 90%. Okay, I didn't emphasize that before, but that is what it is. So 2 cancels out. Okay, what is the value for 90%? 90% confidence intervals, that means I need to read 95, which is 1.645. 1.645. So z value of alpha percent is this 2.326. Okay, so what this means is that my critical region is from 2.326. Now, what is 2.326? I think I will be able to read that. That's 99%. So this area is 99%. That means I've left out 1% of this side. But if it's a confidence interval, I must also leave out 1% on this side. So if the significance level, the tails have 2%, then the confidence level should be 98%, 100 minus 2%. Okay, so this central area was 99, this central area was in 99%. It all to the left of 2.326. Okay, let me check if that is the correct answer. Yes, that is indeed the correct answer. It says find the probability that the 90% confidence intervals contains the population mean given that the alpha percent. So the alpha percent contains the population means that there's a 98% chance of that happening. What is the probability conditional? This is a conditional probability that the 90% confidence interval also contains that uh, mean. So it's going to be 90% over 98%. Okay, there's a 98% chance in the denominator that you are right. That's the given that condition. What is the condition in the numerator? That you are 90, that the true population mean is in the 90% confidence interval, that the probability is 90%. So this conditional probability, that's a 1 mark question, nothing to worry about. That's 49, 40 over 40, 45 over 40. Okay, question number 5. Question number 5 says it is known that 20% of households in a country have more than 4 contain more than 4 people. Lakshmi believes that in her town the percentage is lower than. Okay, this looks like a hypothesis testing question, so I'm going to write this first. She chooses a random sample of 40 households in her town and notes the number which contains more than 4 people. Then carries out a test at the 2.5% significance level. Using a binomial distribution, find the probability of a type 1 error. So type 1 error is always through trial and error. What number am I going to try? I don't know for sure. I am first trying out probability of x less than or equals to 2. My judgment will be based on whether it reaches the significance level or not. Okay, so 0, 1, and 2. So 40 C 0.8 power 40 point power 0 plus 40 1. Okay, you have to write this once so that when you're doing trial and error, the examiner knows exactly what numbers you've taken. I am going to use my cumulative function on my calculator. Calculate that quickly. 240 and point. So I am getting 0.0. 0.0794. It's a very small probability, which means that I will have to bring that up. So I'm going to calculate probability of x less than or equals to 0.00794 plus 43.8 power 37.2 power 3. Let's rapidly come up 0.02846. That's now greater than 2.5% actually. So 0.00794 should have been the correct number. That's the probability of type 1 error. The rejection region is less than or equals to 2. Okay. Yep, that is the correct. Although there's this mentioned here that if they've sort of shown this, this is also fine. State the rejection region's x is less than or equals to 2. Lakshmi finds that exactly 2 households in her sample contain more than 4 people. Okay, because explain why it is impossible. Because she will reject H naught. Type 2 errors are made when you fail to reject H. Okay, question number 6 quickly. The masses in kilograms of large and small bags of potatoes have independent distribution. Listen that. Find the probability that the total mass of a randomly large bag of potatoes is, and a randomly chosen small bag of potatoes, large plus small, is more than 3.55. So large plus small has a normal distribution then. 2.5 plus 0.8 gives me 3 and 0.07. Okay, means get added, variances get added. So z is greater than 3.55 minus 0.3 divided by root of 0. Z greater than 0.945. Eight two 7.7. Okay, 1723. I think that should be the correct answer. Yeah, 0.172 for correct to 3 significant figures. Let's see what part B says. It says find the probability that the large potatoes is less than 3 times the small potato, L minus 3s. So there's a new letter called difference. So difference is L minus 3s. Okay. So the mean for L was 3. No, sorry, 2.5. And that was 0.8. So 0.8 comma. Okay, that's the mean. It was 0.05 plus, you don't subtract for variance, 0.0. Okay, so normal distribution 2.5.1, I think. 0.05 to plus 3 square into 0.0. I'm getting 0. Difference is less than 0. C is less than 0 minus 0.1 divided by root of 0. 3 less than minus 0.209. 5 of minus 0.209. 1 minus 5.9. 0.209. Okay, so 5793 plus 35, 5828. I don't know if that's correct. 0.4172. So 0.417 should be my final answer. That's an easy question, a lot of marks. Let's look at question number 7. That's the last question on this exam. Doesn't sound very difficult, but let's just do. Uh, it's a quadratic function. It says find the probability that in a randomly chosen test longer than 4.5 minutes to complete the test. So from 4.5 to 5, I have to integrate all of this. I'm going to expand this because it's best to integrate it with an expansion. So it's going to become x cube over 3 minus 8x square over 2 plus 15x. 4.5 and 5 minus 3 over 4. I have to show you the limits. Okay, so those are lengthy calculations. Start doing them. What's 5 cube divided by 3 is 125 over 3. 175 minus 4.5 cubed divided by 3. That's 243 over 8. 4 into 4.5 squared, 81. 135 over it. Okay, so I'm now going to type everything on my calculator as it is, because I've already shown you a lot of working. Into minus 3 divided by 4. So I'm getting 5 over 32. I don't know if that's the correct answer. Yes, that is the correct answer. That is as much working as you need to show. It says write down the median of x. Median is always the line of symmetry. Now, if you see these two, they have intercepts at 3 and 5, which means that this curve is like this. What is the line of symmetry going to be? It's going to be at 4. I'm going to go and just say 4. At 4, the area is going to be divided into two halves. Okay, it says without performing an integration, use your answer to part A to find this. Okay, again, I'm going to draw this curve for you and say that this is 3, this is 5, and the central value is 4. Now, what have I found out right now? A probability from 4.5 to 5, which is 5 over 32. So 4.5 to 5. So this blue area is 5 over 32. I'm asking you now for 3.5 to 5. Okay, so 3.5 to 4.5. So I'm asking you for these two areas basically. Can I also say that this is 5 over 32 then? Why? Because it has to be in symmetry. Okay, so it's just 1 minus 2 times 5 over 32. So that's 32 minus 10 over 32. That's 22 over 30. Okay, that's 11 over 16. I think that's the correct answer. That brings me to the end of this exam. Very short exam. I did it in about 25 minutes, and that gives me enough time to go on and check.